So today we're going to talk about Dalton's law, and this is a law that has to do with pressure, but it also has to do with some math, which means I need to double check that you remember all of your sig fig rules. Most of Dalton's law is going to have to do with addition and subtraction, and so remember the sig fig rule when you're adding and subtracting is that you're going to round your answer to the least number of sig figs after the decimal. Don't look at the whole thing, remember to only look after the decimal. So we're going to do a little bit of practice with this and make sure that you remember how to do it. So if you look at this first one, and you can go ahead, grab your calculator, just put that whole thing into your calculator. Just add up those three numbers. And it says that you get 180.41. But we have to look at the sig figs with the rest of the numbers to figure out where are we going to round our answer. So this number right here has 2 sig figs after the decimal. Right here we have 1. And over here we have 2. The least amount out of all of that is to have 1 sig fig after our decimal. So that means, I'll move this over, that answer that we got, we're going to end at 1 sig fig after the decimal, which is right here at that 4. So I'm going to chop my number right there. I'm going to leave the 180 and take a look at that 4. Should I leave it a 4 or should I round it up? If you look at what's right behind it, there's a 1. Since a 1 is less than a 5, you leave the number alone and just leave it at a 4. And then just take the units from what you had and your answer is 180.4 milliliters. So let's try this one too. So first thing is just go ahead, get the math out, put those numbers into your calculator. And your calculator says it's 140.59. Now let's see if we can figure out our sig figs. Look after the decimal in your original numbers. There was 1 sig fig right here, and there were 2 sig figs over here. This is the least amount, which means we want 1 sig fig after the answer or 1 sig fig after the decimal in our answer, which will be right here at that 5. So you're going to leave the 140. The only thing that you have to decide is that 5 right there. Should I leave it a 5 or should I round it up to a 6? Look directly behind it. Since there's a 9, it's bigger than a 5. That's going to make your number round up. So instead of 140.59, we're going to round it to 140.6 ml. So take a minute right now. You're going to see if you can do these 2 questions. Pause the video and then come back and compare your answers with me. All right, how'd you do? Let's see. When I put this first one into my calculator, it just says 1.36. If I look after the decimal, there's 2 after the decimal here, 1 here. That means my answer should have 1 after the decimal as well. I'm going to round it up to 1.4 because of the 6 that was after the 3. For the second one, when I put it in my calculator, I get 345.6922. So a pretty long number, but remember we want to look after the decimal in our original numbers to figure this out. So there's 1 here and 4 over here. I only want 1 sig fig after the decimal to make it the least. That's right here at this 6. So I'm going to leave the 345 and I'm going to round it up to a 7 because of that 9. So I need you to use those sig fig rules as we start to talk about Dalton's law of partial pressures. So Dalton's law of partial pressures is basically that the total pressure equals the sum of all of the other pressures. So basically we're just going to be adding some numbers up. So this is kind of a nice easy law. You just have to remember sig figs. So if I look in this question, it tells me that I'm looking for the total pressure. So I don't know what it will be after I've added everything up. But it does tell me that I have 2 partial pressures in here. And so maybe you want to highlight those numbers, help you find some things. I see right here that I've got neon with that partial pressure and argon with that partial pressure. So basically all that I need to do is add up 542 plus 234. That gives me a total pressure of 776. Now for your sig figs, both of these original numbers had nothing after the decimal, so we just want nothing after the decimal here, which we already have. Pull the units right out of the question, and your final answer is 776 mmHg. Every once in a while, they're going to try to trick you with percentages and Dalton's law, but basically you just have to remember your percentage rules. So if I look in here, again, maybe you want to highlight to find, oops, not like that. Maybe you want to highlight to find your numbers. So I see that, I see that, I see that. And so this tells me already that the total pressure, get my pen back, the total pressure, oh, come on. Maybe. There we go, is 670 mmHg. But now I can't just add up 13 and 87 because they've given me percents. Whenever they give you percents, you just basically need to remember the math that you know. And so what you're going to do is you're going to do the percent over 100 times the total pressure. So we're going to do that for both of the things that we're given. So let's do it for oxygen, because that's what they asked me about. So the percent that they give me for oxygen is 13 divided by 100 times the total pressure of 670. So throw that into your calculator and you get 87.1. That's all you have to do. Just double check your sig figs. Here we were multiplying and dividing. You know that sig fig rule is just go with the least overall. This number that I used from the question had 2 sig figs. So that means I'm going to make this have 2 sig figs and leave it at 87. And my unit comes from this, mmHg. So what I want you to do is see if you can finish this page. And then when you're finished, come back and compare the answers, and I will put them up on the screen. Okay, so let's see how you did. Here are all the answers. I'm just going to scroll through them quickly for you. Go back up to the top one more time. Now, if you got something wrong, I want you to try to figure it out on your own. See if you can figure out where your error was. If you can't figure it out, put a little star next to that question, and we'll talk about it the next time that we're together in class. What I want you to work on now is see if you can work on this same Dalton's Law idea all on page 10.